Okay, we are going to continue the same point in second half. In this half, that is in last half, we have studied absorbance and transmittance. That is, transmittance is nothing but it is incident light radiation ratio of transmitted light radiation divided by intensity of incident light radiation, that is I upon I0. So we have cleared absorbance, transmittance, Beard's-Lambert's law. Now, whenever any organic molecule exposed to UV light radiation, that is range 200 nanometers to 800 nanometer, which type of energy level changes takes place? That is, in UV light radiations, in the organic molecule, the energy level takes place, change in energy level takes place at electronic energy level. Means there occurs electronic transitions. सगळ्यात महत्वाचा पॉइंट आहे हा, लक्षात ठेवायचा एवढं तुम्हाला. एखादा ऑर्गॅनिक मॉलिक्यूलचा आपल्याला ॲनालिसिस करायचं आहे. तो मॉलिक्यूल जर आपण अल्ट्राव्हायोलेट रेडिएशनच्या लाईटमध्ये ठेवला तर कुठल्या एनर्जी लेवल चेंज होतात? तर तुम्हाला सगळ्यांना माहिती आहे की 3 प्रकारच्या एनर्जी लेवल आहेत. कोणत्या 3 प्रकारच्या? इलेक्ट्रॉनिक एनर्जी लेवल, व्हायब्रेशनल एनर्जी लेवल, spin energy level. Out of these 3, in UV spectroscopy, the changes takes place in case of electronic energy level. Electrons are transist from different energy level. So, when molecule is getting excited by absorption of UV light radiation in electromagnetic level or electromagnetic radiation region, then the electrons are promoted from ground state to excited state or bonding molecular orbitals to anti-bonding molecular orbitals. Listen carefully. When molecule is exposed to light radiation, there occurs excitation of electrons due to absorbance of what? Electromagnetic radiations or light radiation in UV visible region. Most important thing, when it absorbs in this region, the electrons are get excited or promoted from ground state. Ground state is bonding molecular orbital, to excited state, or from highly occupied molecular orbital to lowest unoccupied molecular orbital. Such type of electronic transition takes place. Now see, all the molecules are having no similar structure. Suppose we consider alkanes. Alkanes containing all type of single bond. Alkane मध्ये सगळे काय येतं? Single bond आहेत. If it containing all type of single bonds, then which type of bond is present? There are 2 types of bond. One is the sigma bond, another is the pi bond, or one is the sigma bonded molecular orbital and another one is the pi bonding molecular orbital. Third orbital is which type? That is non-bonded molecular orbitals. तिन्ही molecular orbital व्यवस्थित लक्षात ठेवायच्या. Those compound containing single bond contains only sigma bonding molecular orbital, sigma bonds. Those containing double bonded system, it contains sigma bond as well as pi bond. त्यामध्ये सिग्मा बॉन्ड पण असतो आणि काय असतो पाय बॉन्ड पण असतो. म्हणजे टू टाईपच्या मॉलिक्युलर ऑर्बिटल असतील, एक सिग्मा बॉन्डिंग मॉलिक्युलर ऑर्बिटल, दुसरे पाय बॉन्डिंग मॉलिक्युलर ऑर्बिटल. अँड थर्ड टाइप, those compound contain, for example, aldehydes. Aldehydes containing carbon double bond oxygen. It contains sigma bond, pi bond between carbon and oxygen is having two electrons. त्याला आपण म्हणतो नॉन बॉन्डेड पेअर ऑफ इलेक्ट्रॉन. These are the non-bonding molecular orbital. मीन्स अल्डिहाइड्स आणि कीटोन मध्ये तीन टाईपच्या ऑर्बिटल्स आहेत. सिग्मा बॉन्डेड molecular orbital, pi bonded molecular orbital, and non-bonded molecular orbital in the form of lone pair of electron. Hence, all these type of molecules, alkane shows different types of transition because it contains only sigma bond. Alkenes, dienes, trienes, polyalkenes containing sigma bond as well as pi bond, and aldehydes and ketones contains sigma bond, pi bond as well as non-bonding pair of electrons. Hence, whenever we are exposed alkenes, dienes, trienes, tetraenes in this way, or aldehydes and ketones in ultraviolet radiations, due to presence of different types of bond or bonding molecular orbitals, different types of transitions are observed. And hence, in spite of alkenes, alkene, polyenes, tetraenes, dienes, and aldehyde ketone shows different range of absorbance, and hence such type of molecules can be distinguished from each other. And that's why in UV radiations there are 4 different types of set of transitions is observed. Means hence now we have to study the types of electronic transition. All of you are mostly familiar with this diagram. That is, there are 4 major types of transitions are observed whenever molecule is exposed to UV light radiation. ज्यावेळेस मॉलिक्यूल UV light radiation ला काय केला जाईल, एक्सपोज केला जाईल. So first type of transition is, that is the transition of sigma to sigma star transition. Sigma to sigma star transition. This type of transition, in this type of transition, electrons from bonded sigma molecular orbital takes place towards anti-bonding sigma bonded molecular orbital. It is represented as sigma to sigma star transition. इथे कुठल्या टाईपचं ट्रान्झिशन होतं, इलेक्ट्रॉन्स आर present in ground state sigma molecular orbital. They are excited from sigma bonding molecular orbital of ground state towards lowest unoccupied molecular orbital present at top position of sigma anti-bonding molecular orbital. And this transition takes place in case of all types of alkane. सगळ्या टाईपच्या अल्केन मध्ये कुठलं ट्रान्झिशन दिसतं आपल्याला फक्त, तर ते ट्रान्झिशन असतं सिग्मा टू सिग्मा स्टार. ओके, इन डायग्राम वी कॅन ऑब्झर्व that is, this is the first set of transition, that is sigma to sigma star which requires highest energy. This diagram shows energy versus different types of transitions. Means according to diagram मध्ये तुम्हाला दिसतंय की सिग्मा आणि सिग्मा स्टार मध्ये सगळ्यात मोठं गॅप आहे. This transition requires highest energy to excite from ground state to excited state energy level, and that's why this transition shows what is the relationship between energy and wavelength. The energy and wavelength is always reciprocal of each other. Highest energy required for transition, absorbance in terms of wavelength is very low, and that's why in case of alkanes, as the transition takes place from sigma to sigma star, required energy is highest. That's why absorbance in terms of wavelength or in terms of nanometer, it is below 200 nanometers. अल्केन नेहमी ॲब्सॉर्बन्स दाखवतात 150 पासून 180 नॅनोमीटर पर्यंत जास्तीत जास्त. But our UV light radiation range is 200 nanometers to 800 nanometers, and that's why all types of single bonded compounds including alkane are inactive towards UV light radiations. Is it clear? व्यवस्थित समजून घ्या की सिग्मा टू सिग्मा स्टार ट्रान्झिशन इज इनएक्टिव्ह टुवर्ड्स UV light radiation. This is the first type of transition which is shown by particularly all types of alkenes. थोडक्यात ज्या मॉलिक्यूलमध्ये सिग्मा बॉन्ड आहेत तिथे हे ट्रान्झिशन दिसेल, फक्त सिग्मा, नॉट अदर. Second type of transition is N to sigma star and N to pi star. N to sigma star and N to pi star. In this transition, non-bonded molecular orbital electrons from non-bonded molecular orbitals are get excited towards anti-bonding molecular orbital, that is anti-bonding sigma orbital or anti-bonding pi orbital. The transition is represented by N2 sigma star and N2 pi star, and such type of transition takes place in non-bonded to sigma star, that is aldehyde and ketones. ऑक्सिजन वरती नॉन बॉन्डेड इलेक्ट्रॉन असतात, ते सिग्मा स्टार मध्ये जर गेले तर ट्रान्झिशन असेल सिग्मा टू सिग्मा अँटीबॉन्डिंग मॉलिक्युलर ऑर्बिटल. तेच जर पाय बॉन्डेड सिस्टीम मध्ये गेले ते N2 pi star, and this transition shown by the molecules like alkyl halides, aldehydes and ketones. So N2 sigma star and N2 pi star, this transition is shown by alkyl halides and aldehydes and ketones. Okay, what is the energy range? Energy range is like this, that is N2 sigma star, this requires lower energy as compared to sigma to pi star, and that's why wavelength is higher, absorbance is higher. Second thing, that is as compared to N2 sigma star, N2 pi star, this transition is require again lower energy, that's why wavelength is higher. So sigma, pi and N, these are the bonding molecular orbitals. Pi star to sigma star, these are the non-bonded anti-bonding molecular orbitals, that is anti-bonding molecular orbital. Okay, so this is about the second type of transition. Third type of transition is the pi to pi star, and this pi to pi star transition requires pi to pi star transition. In this transition, electrons from pi bonding molecular orbitals are excited to pi non-bonded molecular orbitals, pi anti-bonding molecular orbitals, pi anti-bonding molecular orbitals, and such type of transitions are shown by alkenes, alkynes, aromatic compounds, carbonyl compounds like aldehydes and ketones. This transition requires very low energy as compared to N2 sigma star. N2 sigma star. So these are the four type of transitions. In these four type of transitions, see the relationship. Higher the energy required for transition, lower is the absorbance. Lower energy required for transition, highest is the particular wavelength. So these are the four type of transitions. Now we have to see the relationship between energy and other type of transitions. Energy and other type of transition. So just we have discussed N to pi star requires very low energy, then pi to pi star, then N to sigma star, and sigma to sigma star requires very highest energy for excitation from ground state to excited state. Is it right? Hence, trend, those transition requires highest energy. Absorbance is lower. That is wavelength in UV spectroscopy is lower. Now, according to this, depending on absorbance, intensity, shift and UV spectrum, there are two major terms we have to study. One is the bathochromic shift and second one is the hypsochromic shift. Okay, so during the particular UV spectroscopy, we are going to study two terms: how much energy is absorbed and the absorbed energy and its wavelength. Absorbed energy and its wavelength. Higher the absorbance, lower is the wavelength. Okay, so during this absorbance, what happens? Whenever any organic molecule is absorbed at higher wavelength, such type of higher absorbance or the wavelength is higher towards longer wavelength, then such type of shift is called as bathochromic shift. That is, in bathochromic shift, absorption takes place towards higher wavelength or highest lambda max value. Absorbance towards higher wavelength. Then such type of shift is called as bathochromic shift, or it is also called as red shift. See the graph. That is bathochromic shift. In bathochromic shift, absorbance of that particular UV light radiation takes place towards higher wavelength, means lambda max value is higher. Such type of shift is also called as red shift. Red shift. Secondly, hypsochromic shift. Absorbance of wavelength or absorbance of light radiation takes place towards lower wavelength. Lower wavelength, higher is the energy. Lower wavelength, then such type of shift is called as a hypsochromic shift, or it is also called as blue shift. Hypsochromic shift, blue shift, lower absorbance, shorter wavelength, absorption towards shorter wavelength. Bathochromic shift, it is also called as red shift. In this case, absorption takes place towards longer wavelength. Absorption takes place towards longer wavelength. So there are two types of shift are observed during the experiment, that is bathochromic shift, that is absorption towards higher wavelength, and hypsochromic shift, absorption towards lower wavelength. Bathochromic shift is called as red shift, hypsochromic shift is called as blue shift. Okay, so in this particular lecture we are going to study it. काय काय स्टडी केला आपण त्या लेक्चर मध्ये. फर्स्ट we have studied, again I will repeat from first slide. या लेक्चर मध्ये आपण काय काय स्टडी केलं दोन्ही हाफ लेक्चर्स मिळून. तर UV स्पेक्ट्रोस्कोपी, प्रिन्सिपल ऑफ UV स्पेक्ट्रोस्कोपी, measurement of UV spectroscopy. By using UV spectroscopy, conjugations can be determined. Range of UV spectroscopy, कुठल्या रेंजमध्ये आपण स्टडी करतो. UV spectroscopy is always based on Lambert-Beard's law. This we have studied. Then four type of transitions. Then types of shift. That is shifting of lambda max value towards higher wavelength. आता तुम्ही म्हणाल का शिफ्ट होते, ते पुढे आपण उदाहरण घेऊन पाहणार आहोत. पॅथोक्रोमिक शिफ्ट, हिप्सोक्रोमिक शिफ्ट and relationship between energy and wavelength. हा सगळा स्टडी केलाय. Now what is your duty? Watch this video lecture carefully. व्यवस्थित वॉच करा दोन्ही लेक्चर. And then you have already data at TY level. TYचा पूर्ण डाटा हा तुमच्याकडे आज जर शिकवला तो तुमच्याकडे आहे. एकदा लेक्चर ऑब्झर्व करा आणि एकदा TY particularly notes ऑब्झर्व करा. You can understand everything. In next lecture tomorrow we are continuing the same point. Okay, thank you. If you have any query after end of the week or 1 to 2 days, you can directly ask on my personal WhatsApp वरती विचारा. प्रत्येक झालेल्या लेक्चर वरती मी त्याचं सोल्युशन तुम्हाला सांगत जाईल. ओके, इट्स नाव. थँक यू. हॅव अ नाईस डे. स्टे सेफ ॲट युअर होम. ओके.